There we go. Anyway, so I just wanted to make everybody aware, if you're not already aware of this site here, this Miklor, M-I-K-L-O-R. I hope everybody can see that okay. It's the ultimate de facto everything about Baofeng radios. And it has antenna reviews here for you as well. I don't know if everybody's familiar with that. And they talk about this, and this is the one that Judy is considering, this guy here. All you have to do is click on it, and they send you to Amazon and what the best price is and all sorts of junk. And there's a bunch of different sources to buy them. This happens to be a pretty good one. So, and if you're not happy with something, you can return it, which is really good. And then Anirudh had a question. Let's see, is Anirudh in? Yeah, let's see if he's signed in yet. Yeah. So Anirudh asked me if I buy 2 or 3 Baofengs and program the FRS GMRS frequencies, can they be used as walkie-talkies? The answer is no. The reason for that is Part 97 very, very clearly identifies how much power you can have on FRS GMRS radios. Those are the ones that you buy in Walmart or Target or whatever. And they have to be less than a watt. That's the law. And the lowest you can turn down your Baofeng is over a watt. It says a watt, but it's actually over a watt. So it's because of that criteria. Will anybody freak out over it? No. Just, you know, put it on the low power setting. You end up with about 1.3 watts. And I don't think you'll have a problem, but just make sure you turn the power down. Okay? And then next, no problem, question. Next question, is it correct that the Baofeng units have a better range than walkie-talkie from Walmart? Absolutely. And that's because they put out more power. The walkie-talkies that you get in Walmart start at about 0.3 watts, and they'll go up to 0.8 watts depending on the individual unit. So again, I don't think it's a terrible, terrible breach of the law here. Just keep the power at 1 watt, and it'll also disrupt the signals of other FRS GMRS radios. If you transmit any more than that, you can you definitely won't be popular. If other people are using FRS radios and you come in at 5 watts on FRS frequency, they will not be your friend. Can a ham with tech license communicate to other hams in approved foreign countries and to space stations? Absolutely. Absolutely. You just got to stay within your frequency band. You don't necessarily have to be a general licensee to do that. You can do that as with a technical license, technician license. Just stay in the bands that you're supposed to be. Otherwise, they can't log the conversation. And if they spend time with you and they find out that you're illegally on that frequency, again, you won't get any Christmas cards from them. Okay. And then the next question is, you say you're a QRP person. What controls the wattage of a ham radio? So I know there's settings in the Baofeng, low, medium, and high. So yes, so all radios have power variations, so you can reduce the power. And on my ICOM 7000, I can actually turn the power down to whatever I like. I can turn it down to 1 watt if I like. All the radios are. The Baofeng only has 3 settings, but most other radios are variable, much more variable. I hope that answers your question. And you have the brand new BF F9 V2. Ooh. How do you like the Nagoya antenna, the 771? Is that working for you?
It's pretty big. So it doesn't, hold the radio. I mean, the radio, if you put it on a table, it'll probably fall off. It to be that long, and it's a little heavy, but it's great. It's much better than what the rubber ducky.
Yeah, yeah. And then I got one more question, and it said, "Hi Joe, is it okay to start with the UV 5R, absolutely. And it's absolutely okay to start with that radio. I do like the 8 a little bit better. I think it's a little bit better made. That's why it's double the price. But still, for $60, I think it's a good deal. And just so everybody knows one more time, so this is miclord.com. This is what I recommend that everybody use to find out about their radios. So we're going to start just a quick tutorial on this. So the biggest problem with the Baofeng radios, the Chinese radios, is not the radio, it's the cable and the drivers that you use. So the cable, excuse me, the cable, you got to make sure you buy the cable from a reputable source. Inside the, I'm trying to make this bigger, hold on, so you can see. Okay, so inside the cable, right here, the part that gets connected to your computer, and it's called a prolific chip. And as with a lot of things from China, the are fit. They're just copies. They didn't want to pay the royalty. And that's where you run into a problem. So you have to have the right driver, and you got to make sure if it does, the chip inside here is probably a phony. So be careful where you buy the cables from. And then down here is where the drivers are for the radios. Okay, and you can download the radios, and they talk about the cable as well. And this is the same warning here. Okay, so the issue that is most common is you have to make sure you have this driver, 3200. That's the most important thing that you can do to avoid any problems. If you don't have this driver, it may look like it's working, but the radio doesn't work correctly. And I think we had a question on that a couple of weeks ago, about somebody who tried to program the radio, and they were still having difficulty. This most commonly is the issue. So the way you check for that is you go to My Computer, right? So I'll do this so everybody can see this. I guess not. So I'm right-clicking on My Computer here. I'm going to go to Manage, and then this box opens up here, okay? And there's the Device Manager, all right? And when you click on the Device Manager, it tells you everything that's on your computer. And you go to Ports, and you make sure that this doesn't have an asterisk on it. If it does, it's not connected correctly. It's important, so I just right-clicked on this, and I go to Update Driver Software. So it's very important that you click Browse My Computer, and then from here, don't just hit Next. Click on where it says, Let me pick from a list of device drivers on my computer. So you click that, and you'll notice that there's 2 drivers that come in the package. There's 3.467325. That's pretty much newer than this driver, which is in 2007. But in fact, the one you want is the older one, 3.2.0.0. This is a fake. Okay? So you don't want this one. You want this one. Okay? That's a little trick. This was trying to address the phony prolific chips that were in the cables, but it wasn't successful, and they don't work well at all. So you want the 3.200 driver. And then as soon as you have that, this will work correctly. And since there's no exclamation mark here, we're good to go. Everybody okay so far? Everybody following me?
Joe, what do you do with a Mac?
I have to tell you that that's above my pay grade here. Somebody did it with a Mac, right? Who did it with a Mac?
I did. Anirudh
yeah,
did it.
Go ahead. The floor is yours.
I basically just went to that website and downloaded the Prolific driver. And with a Mac, you have to install another software, which Mike the website talks about that you were on, Joe.
Miclor? Yeah.
Yeah, Miclor.
Yeah.
And they talk about that you need to install this software first, and it's only a one-time deal. And then after that, you can go ahead and install the driver and then the Chirp software.
Okay. I hope that answered your question. So I'm a big.
I'm
sorry. Go ahead.
This is Bill. The other night I had indicated that my first crack at loading from the Mac had run into some problems. I went back to the Miclor website and pulled down the daily update for the software, and I ran that last night, and it worked beautifully.
Yeah, yeah. Okay.
The other key was on the software, when you bring up the page that you had up a little while ago for loading frequencies and so forth,
Right.
on that there's an instruction to turn the volume up all the way. And I think that had something to do with it, too. I missed that the first time around.
Yeah, agreed. Agreed. We'll get to that in just a second. So thank you, Bill. So Chirp is the software that's most commonly used, and it's actually very, very cool. So I just went to Yahoo or Google, doesn't matter, and I typed in Chirp, C-H-I-R-P, and then it takes you to the home site. Just go to downloads, and then you'll see the most stable ones are listed here, okay? But if you want, there are daily downloads. So this is the one for Windows, this is the one for Macs, for Linux, and then over here is the latest daily builds, okay? So you click on that, and it takes you to the daily builds. I'm worried about this. So these daily builds, sometimes, most of the time, they work fine. Sometimes they don't, okay? So, for example, I didn't have much luck with, I just downloaded this just before class. I didn't have much luck with my setup on mine, so I had to revert back to an earlier version of Chirp, and that worked okay. So, you know, if it doesn't work, just go back to an earlier version of, and they list all the versions. So you want to run Chirp, and then it loads pretty easily. Same thing for the Mac. They have daily updates for the Mac as well. So if we click here, again, it should take you to the Mac version, and there's a Mac version.
App.zip. It's app.zip.
AppZip is the one.
Yeah,
Yep.
It's this guy here. So I have too much fun on my Mac to actually do anything like this, so I haven't done it, although I'm a huge Mac fan. So I haven't played with it on my Macintosh. Shame on me. Okay, anyway, so that said, when you run Chirp, this is what you get. And then going back to our computer, what I do is I always make note of where the port is. So if I go to the port section, it's now set for COM6. This can vary from time to time, so you always want to check when this is. And it's the prolific USB to serial port connection, COM6. That's how I know it's the device that I want, okay? And then to download from my radio, I will just hit radio, download from the radio, and then it defaults to hopefully the right ports. Sometimes there's a bunch of ports in there. It's not very sophisticated, so it doesn't know which one is exactly connected to your radio. So we knew that from looking at the device manager. Make sure you have the right model number here. They list a whole bunch of different models. Okay, and then you hit OK, and there it goes. Okay. And what's nice about this program is it works with a ton of different radios. So these are the frequencies that Seal and I have set in all of our walkie-talkies, handy talk, and all of our radios. So these are the frequencies we use most commonly. So I set at location 0, this is Limarc, right? So it has the tone mode, which is the same consistently. This is my PL tone, which is right here. Okay? I don't care about tone squelch in this particular case. I don't care about any of this stuff. And then the offset's automatically set for you, and all you have to decide if it's plus or minus. Okay? And when you log onto a repeater or you go to a repeater's website, it tells you if it's on or off. Okay? These are simplex channels, these guys here that I'm highlighting, and that's why the offset is set off. Okay? I don't need them because these are simplex modes. So the first one is Limarc, and then I think Mark's in here someplace, maybe, and the rest of these are Aries frequencies. No, so Mark isn't in there. These are all, the rest of these are Aries frequencies on this particular radio. Okay? And that's what we're most interested in. So we can, if the repeater is offline, we program in simplex frequencies direct without the repeater. Okay? And
hey,
that
Joe,
works fine. Yes, sir.
Quick question. If I wanted to, I'm in Illinois, and if I wanted to contact you, how would I do that? Would I hit your repeater, or would I hit my?
You could. So there's a couple of different ways you can do it. Okay. One way is you can use EchoLink, okay, which is a smartphone application, iPhone and Android, free download. You put in your license number, your call sign, and you can tune Limarc. It's absolutely listed, 146.850. That's one way. Second of all is, I don't know what the nearest repeater is to you. You could perhaps link the repeaters together. So your repeater would go to someplace else and then eventually link to the Limarc repeater. That's another possibility. And the other thing, the easiest way is to send me an email, say, I want to talk to you on 20 meters. Then we'll go on 20 meters and we'll meet you someplace and we can talk all night. No problem.
Okay.
Yeah.
Understood.
Okay. I usually hang out on 40 meters. That's the place that I'm normally at. And I'm always playing with different things. Not too much digital. I do some CW and I do phone a lot. So if you guys are interested in where I hang out in 40 meters, and I have a ton of fun there. Anyway, so this is what this radio looks like. I can then save an image of the file, so I would save it as, and then these are all my images, okay, that I have, and I can bring them up or take them down or whatever I want, okay. So this is a special one we did for the American Cancer Society. There was a walk. There was a couple of hundred volunteers. It was at Jones Beach. So they had a whole different frequency list, and I downloaded these here. And then I have my 817, my ICOM 7000, you know, but they're all pretty much the same. Okay, so you can save it there. When I want to transmit this back up to the radio, I can just go radio, upload to radio, hit OK, and if all is well and the planets are in total alignment, it'll work. Okay. This is finished. The Baofeng reboots, and you're good to go. All right. You can also, if you check the sites, you can get information from all these other places: Radio Reference, Repeater Book. There's a whole bunch of different sites that have these files already set for you, depending on your location. Sit there and start typing in the name of these things and all the frequencies and the offsets. You don't need to do that. These are so popular. There's an image file or a CSV, comma delineated file, all over the place. And then if that doesn't work, you can go here, and again, you can import from any data source. It's a pretty cool program. It's a pretty cool program. And then I suggest, and Bill was absolutely right. The other common problem is people don't turn up the volume on the radio all the way. Okay, and if you look at how these things connect, they actually connect through the earpiece and the microphone connection. It's known as a Kenwood connection. So make sure the volume is up all the way, or sometimes you'll get some data corruption in here. Okay. And then what I can do is I can switch radios, put a new radio in here, and if I want to copy and paste something, I can just take the frequency list that I want. Let's say I just wanted these frequencies. I right-click on this, and I can copy it. I can start a new one here, and then paste them in. I can change them around. I mean, it's a pretty cool device. On the F8, you have this power setting, and you can switch between high, medium, and low power. On the UV5R radios, you only have low and high. Okay? So that's the way they work. Any question on this stuff? So you know what to watch out for. Make sure you got the right driver. That's the most important thing that I can suggest to you. And make sure the volume is up all the way. If something doesn't work, it's probably the chip in the cable. Okay, those are my tips for the day. So,
hey Joe.
Yes, sir.
I noticed that if you go to the settings page underneath memories over on the left there,
yeah,
that you can actually set the frequency limits on the radio. Do you recommend setting the frequencies to the limits of the amateur band on 2 meters and 70 centimeters? Joe, are you there?
Okay, I was about to ask if I lost everybody, so yeah. I guess we lost Joe again.
Yep, Joe, if you can hear us, we can't hear you.
Come back, Joe.
Joe, I didn't mean it.
Don't go into the light.
Joe says he's going to call in again.
Can you guys hear me now?
We sure can.
Hello?
We can hear you now.
Sounds good.
Oh, man, this stuff just gets worse and worse. I tell you. I'm so sorry, guys. I'm so sorry. So the thing is, these radios they were designed to be commercial radios in China. They were not designed specifically for ham radio use. So just between us, and we're family here now, right? So you can tune these things to go any place. You can hack them to go any place, all right? And some of the places we want to stay away from, like the Kennedy Control Tower, right? So my suggestion is, do whatever you like. Be careful where you transmit, okay? Because these will transmit on aircraft frequencies, if you play with them too much. And you don't want to get anybody hurt, right? So
Yeah.
I hope that answers your
Now,
question.
for starters, I did set mine just into the amateur bands, just so they didn't accidentally get out of them.
Yeah.
But I understand.
The problem is there's no control. For example, on my Yaesu, I can hear aircraft frequencies. I can't transmit on them. It's locked out. There's no such lockout mechanism on these things. So if I accidentally, I'm listening in my car and I accidentally hit the transmit button somehow, or I sit on the radio or something, I don't want some poor guy coming in IFR on instruments and I mess him up.
Sure.
So you got to be careful with that. Yeah, but these are the advanced settings for things, and you can play with these guys as much as you like. But again, be careful with the frequency ranges. If you guys have ever seen the and ladies, I'm sorry, if you've looked at the little Baofungs, the UV3R, they're only 1 and 2 watt, and those are hacked all over the place. I mean, you can do whatever you want with them.
Joe, this is a question.
Yes.
A thing is, like, if we keep on interfering with some frequencies accidentally every time when we try to experiment it, it's going to cause, like, revoke the license, or is someone going to show up? Like, what's going to consequences?
Well, if you accidentally interfere with fire, police, or aircraft, somebody's going to come looking for you. I guarantee it. I guarantee it.
And
so,
then explanation was sufficient, or like it's totally accident?
Nah. Nope. There is no excuse. There's no excuse. You should know. You should know better. You know.
A question though, Joe. Yeah. Can we use it for Unicom? You know, as a standby radio in a plane? 122.8.
You know what? You could, and that's not a bad idea. To be honest with you, I was flying one time and my antenna just fell off of the aircraft, and I had no way of talking to the tower. And this was at MacArthur Airport here on Long Island, which is pretty busy. I mean, they have commercial stuff going in and out. And I wish I would have tuned my radio, but I was sweating bullets as it was anyway. I was IFR, no radio, and so the last thing I worried about was tuning my radio. I did have my radio with me, but I should have done that. Yeah.
So are these consequences will cause, like, revoke your license, permit?
I think you'll have more problems than that to worry about. And if they catch on the wrong frequency with the wrong equipment. The other question, I'm sorry, who's our pilot who asked me about Unicom?
It's David in Wyoming.
Hey, David. So Unicom is a way of controlling. So when an airport is not controlled, they have the system called Unicom. And it's just a basic way of letting other aircraft know where you are. You don't want to, there's no brakes in an airplane. I know, I've looked. And you don't want to accidentally run into somebody. So you make announcements saying, hey, I'm here, I'm downwind, I'm on base, or whatever you happen to be, whatever your intentions are. But it'll even work, Dave, with on regular controlled airspace. You know, so.
Oh, that'd be great. I can use it for AWAS or whatever. That's great.
Yeah, or ATIS. Yeah, it'll definitely tune in ATIS. Yeah, ATIS is our weather reporting system. Okay, the pilots are responsible to know before or before takeoff, and if they're ready to land, they have to have the latest weather reports so they know what the winds are and stuff like that. And Joyce, it looks like your question was answered on where you can get the prolific driver. Just go to Chirp and pick the radio that you want. They're all really work on the same driver, and make sure you have the right driver. It will save you endless hours of frustration. Okay, so these are more settings that you can play with. The only other thing you do is make sure that these VFO guys here, down here, VFO A bandwidth and VFO bandwidth are set to wide and not, it'll make the radio perform a lot better. Okay, so that's what I suggest that you do. Okay. Any other questions? I'm glad I solved the mystery of Chirp. Okay, so Chirp and Baofeng. Great little radios. I only own about 70 of them, so, and I get a kick out of them. So they're definitely worth the money. Okay, so cool. So we're not going to save our changes. Any question on any of this stuff, right? The only time you use duplexing mode and is set to off is when it's simplex, and that's all you need to worry about. And again, where you look here is I disconnected mine. I'll reconnect my cable. Hold on. So here's what my device manager looks like before the cable is installed. And I'm going to try to do this now. Hold on. So I'm plugging in one side of the cable.
You lose him again?
No Joe, no Mo.
Okay, I'm back. Everybody okay?
Hooray!
We're great.
We're still here.
Unbelievable. Unbelievable. All right, guys, if you lose me, just yell out that you lost me, and I'll dial in again. So you got to give me a minute to dial in. Anyway, I want to finish this chapter.
Oh, can you hear us?
Yep.
Can you hear us even though we've lost you? Okay.
Yep. We can hear. I can hear you even though you lose me. So just let me know that you've lost me, and give me a minute to dial in again. All right. Anyway, I just want to go over, finish up this chapter. The rest of this is pretty easy. The thing I wanted to discuss with you is on the SWR questions. I get this a lot, and I just want to make sure you understand this. Hold on. Let me scroll down here. You know about this stuff from your technical class, no big deal. So here they talk about SWR questions, right? And the questions are daunting. So what's the SWR of a 50-ohm feed line connected to a 200-ohm load? And they word it differently, okay? So here's the deal, guys. Remember that SWR is a ratio. It's something to 1. 1 always exists, so that doesn't change. Right? So it's always something to 1. The easiest way to figure out an SWR question is whatever the biggest number is, it goes on top. That's it. Okay? So here they ask you for a 50-ohm lead line connected to a 10-ohm load. Whatever the biggest number is, it goes on top. And you'll always get the right answer. Okay? For SWR. Same thing here. Okay? Well, this one is easy because it's 50 over 50. Now you know it's 1 to 1. This doesn't exist in nature, but okay, whatever. This one, real easy. Big number on top, little number on the bottom, you get the right answer. Always. Okay? This one, same deal. Okay? Biggest number on top, small number on the bottom, do the math, and it gives you your answer. You'll end up with 6, and it's always whatever number, colon 1. Okay? A lot of people get stuck on that. So just remember that big number goes on top. Okay. And then they talk about impedance matchers. We're familiar with this stuff. These are known as T-networks. They're known as tuners. They're known as pi networks. And all they do is they match the impedance of the feed line and the antenna to your transmitter. So you get the lowest SWR possible. Okay? All right, cool. The next thing you need to know as generals, which we didn't discuss too much in technical, is that cables have their own impedance, and they are a form of resistance. So the longer the cable, the more resistance you have to worry about. And these are the most popular cables, okay? Not a question on a test, but something you should know. These are the different types of cables, and then per 100 feet, what the loss is, okay? So you want to be careful with that, especially if you live someplace that you have the luxury of a lot of land and your wife will kill you if you put up your antenna tower right by the house, so you put it an acre away, and you have to run that feed line. You're going to lose some. Performance there. Okay, and it varies depending on the frequency that you're at. So you'll notice that this is the loss at 30 megahertz, and this is the loss at 150 megahertz. It's quite different. Okay, so it's a consideration that you need to consider. That's really all you need to know about line loss. Okay. All right, cool. So, and this is just a rehashing of the same thing. Okay. All right, cool. We have one more chapter to go, and it's a short one, and then we're going to try an exam, see how we do. We know about this stuff, right? Because we took it in the technical, and they talk about the same layers, D, E, F1, F2 layers. Nothing to worry about. Stuff you already know, okay? And then they talk about a reflection and absorption, all right? And there's a bunch of sites that will tell you the current reflection and absorption depending on the day and your location, okay? And that's about it. And then they talk about skywave propagation versus ground wave propagation. And again, you've considered this stuff in your technical class, so nothing has changed here. They go over it again, and then they talk about long path and short path. Okay, so if you're here in this location here, and you try to talk to another station, which is here, it would make sense that the shortest distance between 2 points is a direct line. So it would make sense that you try here. However, sometimes there's obstructions, there's cloud formations, there could be a million things, and if that doesn't work and you really want to talk to this station, you can point your antenna, your Yagi, in the opposite direction. It will travel around the Earth and eventually hit that station. That's called long path propagation. Sometimes you do that and it works just fine. Sometimes directly pointing the antenna doesn't work as well. Okay? And it only takes about 1/7 of a second for difference in time. That's how fast it travels. So it's virtually instantaneous. Okay? Long wave, short wave. That's it. I'm sorry, short path, long path. All right? Then they talk about the sunspots and cycles. Okay? The sun kind of gets aggravated with us every 11 years, okay, and is known as the sunspot or solar cycle. And right now it's starting to rise again. The lowest, it was at its lowest point in 2010, and now the sun's starting to kick up a little bit more. We're in year 5 of that, and it will continue to make our life a little bit more difficult for the next 6 years. And then it starts to drop off again, and you should be aware of that. The reason that you go through this, and we go through this, is so you know what's controlling your signal, because we're expecting you to do some very long-range communication, and you need to consider these things, okay? And does it totally wipe us out? No, it's not so bad, okay? So they go into more detail here as to what's going to happen, and the 40 meters pretty much works all the time, and it's pretty cool. Okay, solar activity. There are sites that will give you the current solar activity. There's a million of them on the. Just type in ham radio solar activity, and you'll end up with 4 million sites, and they'll tell you what's happening right now currently. Okay. All right. Cool. I need you to know these things right here. Okay. And it's on your study sheet. I need you to know what the solar flux index is. I need you to know what the K index is and what the A index is. Okay. So it's very important because there are questions on the exam. Bill, you took the exam. Did they ask you a K or A index question?
No, I seem to recall it was a solar flux index question.
Okay. Okay.
Hey, Joe.
So,
Yeah, one of the three.
yeah. Yes, sir.
Mine had the K-index question on the test I took.
Oh, you did? All right. Great, great, great. How did you make out on your exam?
I missed 3 on my general, and the technician I knocked out of the ballpark.
Way to go. Wait, and you missed 3 on your general? Wow, that's awesome. That's awesome. Good job. Okay.
Email about how they notified me the first time.
Oh, that's right. You told me. That's right. You emailed me. You said they made a mistake?
Yes, they put my paperwork in somebody else's file and their paperwork in mine, and told me that I crashed and burned on my general, and then called me later and told me that I got my general.
Those rotten, no good for. I'm telling you, I would protest. That's awful. That's awful. Well, congratulations. Anyway, that's great. That's great. When I first took my technician's exam again, many years ago, they lost my answers. Sorry. So it happens. So don't be too disheartened because you never know. So there's living proof. Okay. Anyway, the other thing I want you to know here is maximum usable frequency, lowest usable frequency. Okay. So these sites will tell you what you can expect is the lowest frequency on the band and the highest frequency on the band. Okay. And that varies. It varies with the time of day, the season, it varies all the time. And not that you can't go there, it'll just sound dead. There just won't be anybody talking, or or digital modes or CW. So you just need to know maximum usable frequency and lowest usable frequency. Okay, that's all it means. They're trying to help you out here so you don't get frustrated. So you're not saying CQ, CQ, CQ for 2 hours before you find out that the maximum usable frequency is not there. Anyway, and you can go to a bunch of different sites, such as this one, okay, and it'll tell you what's happening, best way to reach them, and what's going on. This is a Northern California site. They take amateur radio very seriously in California, in all of California. So they have an excellent system out there. Okay. And then be ready for solar disturbances, solar flares, coronal holes, and CMEs, coronal mass ejections rather, and they can cause a little bit of havoc. Okay. Another question. I bet you both you gentlemen had this on your general exam. Was this guy here? The difference between UV and X-ray radiation and how long it takes to travel to the Earth. Did you guys have that on your exams?
I did.
Yep. Yep. So
I believe I did too.
Yeah. So you're hearing these from the pros here. These guys ace this stuff. So I wouldn't lie to you guys at this stage. So you want to be careful. Make sure you understand that. UVs and X-rays, it's on your sheet as well. And just make sure you know this one. I can guarantee you this will be a question on the test. Okay? Guarantee it. All right, cool. And then they talk about geomagnetic disturbances, solar wind, okay, and how that affects radio propagation. Again, it's important to know this so you don't get frustrated when you're trying to reach me from wherever you are and we're having some difficulty, and then a couple of hours later we're as clear as can be. So that's the reason for it. Okay. All right. Cool. And these are different types of scatter modes. Okay. So the beautiful thing about amateur radio is we can bounce our signal off of anything. Anything. Okay. So we rely on that phenomenon to go, pretty far. All right. So we can bounce off of different layers of the atmosphere. We can bounce off of meteorites. Remember that your signal travels 186,000 miles per second, so at the speed of light. So it doesn't take long for it to go pretty far in relative terms for us and travel very quickly. Okay, so that's it. That's all you need to know about this guy. And then we had talked about this on Tuesday, and this is a near vertical antenna, and this is a little graphic about how it works. Okay, near vertical incident wave antennas, and they have their purpose, and depending on where you are. So if you live near a mountainous area, that's a perfect antenna for you to consider as one of your antennas, because it bounces off of the F1 layer of the atmosphere, which is higher than any mountain on planet Earth, and you can get your signal through. Okay, that's the purpose for them. This should have been in with the antennas, and I don't know why they do that. All right, and then that's it, Chapter 7. Chapter 8 is safety. I'm not going to go through it. There is really only one question that appears on the exam, and that's how to hook up your belt safety harness. And just remember that the part that hooks on should always point in. Okay, so let's let everybody up for a couple of practice exams. Sure, right? No problem. Okay, let's go there. Let's see how we do here. All right, cool. So let's do this. No, actually, we want to do this one. This is the test we qualify for. I'm going to make this bigger so everybody can read this. All right, and let's see how we do. All right, we're going to go down the list, and if your mic isn't working, that is not an excuse. Okay, so you'll just text me with your answer. And Bradlin asked, is anybody using Chirp on Mac? And Bradlin, you came in late. Yes, we are. And I'm just going to relay the answer to you. Go to Chirp, and go to Miklor, MIKLOR.com, and follow the instructions for using it on the Mac. You have to load another piece of software, I understand. So, but it's pretty self-explanatory, and apparently it works well. And Bradlin says, I can't use it because of the Python requirement. I don't know what to tell you. I'm not the Mac guru here. So if anybody has an answer for Bradlin, he says he can't use the Chirp software for Mac because of Python. So I don't know if there's an answer for that. I will do my best to look into it, and if I find an answer, Bradlin, I'll email you. All right, so we're going to start with Anirudh because he knows this stuff, okay? So Anirudh, what does front-to-back ratio mean in reference to a Yagi antenna?
I'd say D.
All right, he says D, the ratio of forward gain to dipole gain. That's your answer, right?
Yes, sir.
All right, we'll see how that works out for us. Bill, you should be able to, no problem here. Bill, how are radio communications usually affected by the charged particles that reach the Earth from the solar coronal holes?
It is B. The communications are disturbed.
Thank you, Bill. And Bradlin, you can just text me your answer. Which of the following is an advantage of using the binary system when processing digital signals?
D.
D. All of these choices are correct. All right, let's see how that goes. David, you're on. Why must the metal enclosure of every item of the station equipment be grounded? I don't know if David can hear me. Oh, David said D. It ensures that hazardous voltages do not appear on the chassis. Okay. Which of the following is an advantage of a horizontally polar, and who am I picking on here? Hold on. I'm ready to ask the question, and I haven't even decided who we're going to do here. Andy. Andy's been quiet all night. Which of the following is an advantage, Andy, of a horizontally polarized as compared to a vertically polarized antenna?
Okay, let's see.
Take your time.
I'm not really sure, but I think A makes the most sense.
Okay, we'll try that. Just a word of warning here. Again, the general is not that much harder than the technical. They word the questions a lot crummier, though. They do it on purpose just to see if you're paying attention. Frank Jameson. Frank, how are you this evening?
Oh, Frank's here, ready to go.
Okay, this is, all right, Franks. What is the maximum symbol rate permitted for RTTY, or data emissions transmitting on the 1.25 meter and 70 centimeter bands?
I'd say A.
All right, I like that answer. All right, let's go with Greg O'Neill. What is the output peak envelope power from a transmitter if an oscilloscope measures 500 volts peak to peak across a 50 ohm resistor connected to the transmitter output?
All right, I have to get my calculator out.
Okay.
So 0.707.
Mm-hmm.
0.707 times 500 equals that, divided by 2 squared. Oops. 0.70. Am I doing that right? 0.707.
I'm not allowed to respond in this area.
Oh, yeah. Times 500 equals that, x squared divided by 2 equals that, divided by 50 equals 5,000 watts. D.
All right. Let's see if that's right. We'll check it out. And let's pick on Joyce. Joyce, what does the K index indicate? Think of all the physics you learned in this class, right? I don't know if Joyce can hear me. Can you hear me, Joyce? Maybe she can't. Maybe we lost her. All right. Judy, the question is yours. Oh, I'm sorry. Never mind. Joyce said B. Thank you, Joyce. Thank you. Got it. Thank you. So sorry. So, Judy, you're up next. What am a microprocessor?
B.
B. All right. I like that answer. Let's pick on Ken. Ken, which size of fuse or circuit breaker would be appropriate to use with a circuit that uses AWG number 14 wiring? How many amps can I put through that sucker?
Yeah. I'm going to guess B.
Okay. All right. Let's go with Richard Lee. Richard, what signals are used to conduct a two-tone test?
Okay, I'm taking a peek here. I believe
Good time.
I believe it's what you have highlighted there, two non-harmonically related audio signals.
Great answer. Okay, let's pick on Robert. Robert, you were right, by the way, but anyway, your question is different. Which of the following devices can be used for impedance matching at radio frequencies? This is one of those questions that if you read too much into it, it throws you off track. You know? He's going to go with A. Okay. All right. Let's go to Ted. Hey, Ted. What is the relationship between transmitted symbol rate and bandwidth?
I already passed the exam. Why don't you give it to somebody that
Did you really? Congratulations. Congratulations. All right, Tony. Yeah. Tony, you're on. Tony, what is the relationship?
I'm there. I'm looking.
Okay.
It is B.
B. All right.
B is in Bravo.
Okay, sounds great. And so was that Ted or Tony that answered me?
That's Tony.
Oh, Tony. Okay, Tony. We're back up to Anirudh. When sending CW, what does a C mean when added to the RST report?
I'll say D.
Okay. And let's go with, well, Bill, you already took the exam, so I'm going to get past you here. And what I'm going to have you, so I'm going to have you explain some of the answers that they get wrong. How's that? So let's skip past Bill. We're going to go to Bradlin. Bradlin, what statement about a 3-element single-band Yagi antenna is true?
Okay. D.
Okay. And let's go to Andy Eubanks. Andy, what is one disadvantage of a directly fed random wire antenna?
This is only vertical. It's not affecting. B.
B. Okay. And let's go with David. Did you pass your exam already?
Negative. I haven't even taken that technical.
All right. So then
week.
you're
Next week.
you're on. You're on for this one. Which of the following applies when selecting a frequency for lowest attenuation when transmitting on HF?
Well, I'm going to swag it, so bravo.
Okay. Bravo. Got it. Okay, and let's go with Franks. Hey, Franks, what does the Q in QSL mean?
It means acknowledged.
Okay. I acknowledge receipt?
Yeah, C.
All right. Awesome. Okay, got it. Let's go with Greg. Greg, which of the following is required by the FCC rules when operating in the 60-meter band? We talked about this briefly, and maybe I didn't emphasize it enough, but
I was,
I'll give you a hint, okay? So 60 meters is one of those bands we share with the forestry department. I don't know if that gives you any indication.
no, it doesn't help me any, but I will say D.
D. Okay. All right, and let's go with. Okay, you said D or B as in boy.
Boy, bravo.
Okay. And Joyce, you're on. What is one advantage of carrier suppression in a single sideband phone transmission? So I think the way I would read the question is, why would I use SSB, single sideband? A. Okay. And let's go with Judy. Judy, what is an advantage of a digital voltmeter as compared to an analog voltmeter?
I'm going to say C.
C. Okay. I like that answer. All right. And Judy, no, I picked on Judy. Ken. Okay. Ken, what? Got a little too big here. Hold on. And you can't see the whole thing. So let me cut this down just a touch here. Okay. Ken, which symbol in figure G71, which is that one, represents a multi-winding transformer?
And I'm going to go with, I can't see the very top part.
All right, hold on.
Okay, there I can. It didn't matter anyway, did it?
Sorry about that.
That's all right. Let's go with 6C.
6C. Okay. All right, cool. Let's go with Richard Lee. Richard Lee, on which of the following bands is a general class license holder granted all amateur privileges? See, now, to me, this is like lame here, okay? So you've got to know the beginning part of that study sheet. You have to memorize it. But anyway, it's their test, so we have to deal with it. So Richard, you're on the hot seat.
Yeah, I'm looking at my little cheat sheet here that you sent us, and it wouldn't help me at all on this question.
Actually, there should be something towards the top there that reviews this. Maybe not. I haven't seen the study sheet in a while.
I think the study sheet, though, it just shows you which ones are going to be asked. It doesn't, in frequency, it doesn't particularly talk about which bands. So
hold on one second. Let me pull my study sheet. Hold on. I can't believe I left that out. If I did, I did bad. Hold on. I think I did bad. I think I did bad. Hold on. Did I? You know what? I'm not going to show you the study sheet. You take your best guess, and I'm going to look through the study sheet while you do that.
Okay, I'll take my best guess. Give me one more second. Let me see. I think it'll be a shot in the dark, so I'll go with Bravo.
Okay, let's go with Bravo. All right. And Robert, your next question. Can you see that okay, Robert? How close to the lower edge of the 40-meter general class phone segment should your display carrier frequency when using 3 kilohertz wide sideband? They make these questions so obnoxious. Bradlin said that it says that the meter band is next to the frequency. Yeah, that's true. Yeah, but I didn't spell it out, Bradlin. My bad. I should have spelled this out a little bit clearer. Oh well. Anyway, Robert, are you thinking? We may have lost Robert. Just got audio back. I'm sorry. Robert, this one's yours. How close to the lower edge of the 40-meter general class phone segment should your displayed carrier frequency be using 3 kilohertz wide lower sideband? Oh, sorry. He said, hang on. I didn't see that. He says A. All right, cool. And let's go with, let's see, Tony. Let's go with Tony. Which of the following might be used for a field strength meter? think we lost Tony. I don't even see him lit up anymore. You still there, Tony? I think we may have lost him. All right, let's go up to Anirudh while we wait for Tony to sign in again. Anirudh, it's all yours.
Gonna guess B.
Okay. All right, and let's go with Bradlin. Bradlin, what information is traditionally contained in a station log? Did I lose Bradlin also? Looks like oh, no, there you go. Can you hear me? No, I can't, Bradlin, but you answered D. Thank you. I'm so sorry, guys. I apologize that we're having so much trouble with this software.
I am back, Joe.
Okay, sorry about that, Tony. I didn't realize that.
No problem,
Usually
buddy.
you light up here, and I didn't notice you went away, and I guess there was a lag here. Okay, David. Which, if any, band is shared with the Citizens Band Service?
D, Delta.
All right, you know your stuff. All right, Andy Eubanks, what is the approximate action if, when operating on either 30 or 60 meter bands, a station in primary service interferes with your contact? What do you do? Dum, dum, dum.
Move to a clear frequency, delta.
Yeah, yeah. Okay, good answer. Franks, I love that. Why is impedance matching important? How come? Huh?
I would say A. Try it.
A. To deliver maximum power to the load. I like that answer. Greg, what does it mean when a CW operator sends a CL at the end of the transmission?
The answer would be Charlie, listening for only a specific station.
Okay. And let's go with Joyce. Joyce, why must the cases of some large power supply transistors be insulated from the ground? Joyce says C, to reduce stray capacitance. I like that one. Judy, what two devices in an amateur radio station might be connected using a USB device? Not a computer, but an amateur radio. What would you connect with a USB device?
I'm going to say B.
Good answer. I like that answer. All right, thanks, Judy. 10. Which of the following can be determined with a field strength meter?
Say C, Charlie.
C, Charlie. The presence and amount of phase distortion in the transmitter. Okay. And we have Richard Lee. Okay, Richard, what symbol and figure G71 represents an NPN junction transistor?
P as in boy.
Man, you're right on the money there. Wow. Robert, which of the following is a proper way to identify when transmitting using phone on general class frequencies if you have your CSCE for the required elements but your upgrade from technician, he already says Charlie. Okay. Boy, he read it faster than I did. Okay, everybody ready? Dum, dum, dum. Uh-oh. We didn't do so good. Okay. Let's figure it out. Okay. What does forward and back ratio mean? Okay. Anybody want to take a stab at the right answer?
I will, Joe. I think it's Charlie.
Yeah, it's Charlie. So front to back means the power radiated in the major radiation lobe, as opposed to correctly, exactly opposite that. So antennas radiate in a pattern, right? And the main radiation lobe, that part of the antenna that radiates the most, is the forward gain. Exactly 180 degrees opposite of that is the back ratio. Okay, so that's what that means. Again, remember when you take your practice exams, you can just hit this little button, and they tell you what's happening here. All right, this one we got right. How are radio communications usually affected by charged particles that reach the Earth from the solar coronal holes? HF communications are disturbed. And Bill's going to handle this one for me. Bill, explain why we got this one wrong. Which of the following is an advantage of using the binary system when processing digital signals? What do you think, Bill? I think I lost Bill. I don't see him lit up anymore. Did I lose you, Bill? Yeah, I think so. All right. Anybody want to take a shot at this one? Yeah, A. I agree. The advantage of using binaries is that they're either zeros or ones, and they're easy to represent. Okay? All right, cool. This one we got right. Why must the metal enclosures of every item of the station be grounded? To make sure that it doesn't kick your butt is really the answer, okay? Otherwise, if we didn't do this, you could touch the power supply or the radio and get a zip out of life, okay? And which of the following is the advantage of a horizontally polarized as compared to vertically polarized lower ground reflection loss, okay? That's one of the advantages of having a horizontally polarized antenna. All right, next one, we got this one right. How fast can we go on RTTY? On 70 centimeters at 1.25, 56 kilobaud. That I know is on your study sheet. Okay. Whoever, I don't remember the gentleman that had this, poor guy.
That's Greg.
Greg, you had a lot of math. It was pretty close. You didn't have to square it, though. So if you look at it here, okay, and I think that's where you made your mistake on this part here. So you can go through that. This is actually a very, very hard question to answer, okay? And you can look at the response here. So what we did here is we used a bunch of formulas, and the answer was 625 watts. My suggestion is that you review these questions. After a while, you'll get to be familiarized with the question, and you'll know the answer. If you still have a problem computing this before you take your exam, email me, and I'll spend some time with you over the weekend. I don't actually technically leave until April 1st, so I'll be happy to go over these with you, okay? All right, Joyce had this question. What does the K index indicate? And that's right, K, short term, okay? All right, cool. What is a microprocessor? Judy had this one. She nailed it. Awesome job, Judy. Okay. And then Robert immediately knew the answer of this because he must be very familiar with wiring. So 14 wiring, maximum 15 amps. That's the way I remembered it for the test. 14 wiring, 15 amps. Okay? That's probably the only question that they'll ask you about wiring. All right. Two-tone test, non-harmonically related. We got that right. Okay. And this one, how do we match impedance? Okay. Well, this is one of those questions that all of these answers look correct. So we can adjust the impedance by installing a transformer. That was correct. Using a tuner, a Pi network, a tuner, by adjusting the transmission line. We can do that too, okay, if we were so inclined. So the answer was all of these choices are correct. Okay, so we could use all of these choices. Transformer, Pi network, transmission line length to match impedance. Okay. And what is the relationship between transmitted symbol rate and bandwidth? Higher symbol rates require higher bandwidth. The faster we send stuff, the more bandwidth it takes. That's what this question really meant. All right, cool. The C in CW, chirpy. Think of it that way. C in CW, chirpy. Okay. All right, cool. What's the coolest thing about a single band Yagi antenna? Okay. The director element. Remember, this is a 3-element antenna, so it's only got three wires going across it. If I had a drawing pen that worked, I would show you. The director is normally the shortest parasitic element. What directs the signal in a specific direction is the shortest. That's true of any Yagi antenna. Okay? All right, cool. What's one disadvantage of a directly fed random wire antenna? And that was correct. Be very careful with that. You don't get a burn. Remember, random length is any length antenna. It's at its closest point to the feed line. It's exhibiting the most power. You could easily burn yourself. Okay. All right. Which applies when selecting frequency for lowest attenuation when transmitting? The lowest attenuation, or lockout, right? Attenuation means we're not getting a lot of cutoff here, and that's always just below the maximum usable frequency. Okay. What's the Q in QSL mean? I acknowledge receipt. Perfect. Which of the following is required by the FCC rules when operating in the 60-meter band? I meant to tell you this. I think I did, but if I didn't, I apologize. But you should have read the chapter anyway. 60-meter used by the Forestry Department. Okay, and the Forestry Department is huge on dipole antennas. Why? Because they hang them from trees. Okay, it's really, really easy. They literally have a slingshot. They shoot one end of the antenna up to a tree. They take the other side, put it in a slingshot with a fishing weight, and they shoot it up in the tree, and they love dipoles. That's all they use. So
hey,
the
Joe,
answer is yes.
I actually have a story about that random wire length.
Yeah, go ahead.
I did some work for a couple radio stations, as you know. Well, one of them was an AM station here, and we were doing some work out in one of the tower facilities. And there was just a piece of random wire hanging over a board there. Went to grab it, and it blew a hole in my thumbnail.
No way, really?
Yeah, resonant at the frequency they were transmitting on, so when I put my pliers up next to it, you could actually hear Paul Harvey in the arc off my pliers saying the rest of the story.
Oh, my gosh. Yeah, oh, my gosh. Wow. Yeah, yeah. And that's a lot more wattage than we'll ever put out. Yeah.
Oh, yeah, that's a lot of power.
Wow. Well, I guess you learned your lesson. I guess you got that answer right? So you knew that.
Yes.
All right, cool. So anyway, on 60-meter, they're very, very big on your performance if you used any antenna other than a dipole. Okay. So they're big about that, and sometimes they will contact you if you're doing really well on 60 meters. They'll actually contact you. The Forestry Department or FEMA or those guys will contact you and say, hey, what are you using for an antenna? So don't freak out. Okay, anyway. Advantage of using single sideband, it allows us to use our power more efficiently. I thought you guys would get that one. Okay? So the advantage of getting rid of the carrier is you can take that energy and use the power more efficiently to get your signal through. All right, cool. What's the advantage of a digital voltmeter as compared to analog? More precise. That's good. All right, you guys got this right. Which of the following in figure G1 represents a multi-winding transformer? He said 6. That's this guy here. Look at that, I can move this. Isn't that amazing? All right, cool. But I can't highlight it. Anyway, so it's this guy here. All right. And how do I know that? Well, you can see the windings. Lots of windings, little windings. Okay. So multi-winding transformer. That's what a transformer looks like. All right. Excellent. Which of the following bands is general class license holder granted all amateur frequency privileges? This is the answer. I'm sorry that I did not make that specific. in the cheat sheet. You might want to make note of that. So, and add that to the study sheet. Okay, I did bad. Sorry about that.
Click on the little tab up there and open up the show the answer thing. Gives a good explanation.
Okay. Yep. Okay. So you might just want to keep that in the back of your mind here, and that'd be great. Great. Hey, Judy, can you mute your phone? Thank you, Judy. How close to the lower edge of the 40-meter band general class segments and UV display camera? All right, so the key point here is I don't care about the 40 meters. I don't care about any of that stuff. The question is really how close can you get when you know you're transmitting with a 3 kilohertz bandwidth? Well, how close to the lower edge can you get? Well, if you're transmitting at 3 kilohertz above the edge of the band. So if you're going to fall off the planet or the Earth here, right here, and you're at this band edge, and you want to, how far can you transmit? Well, 3 kilohertz from the edge. Otherwise, since the variance is there, if you transmit here, you can actually be transmitting on an illegal frequency. Okay. All right. Cool. Which of the following might be used for field strength meter? Okay. And I think what they were looking for is the bunny hunt thing, okay? And the answer to that is close-in radio direction finding, okay? So you can tell by using your handheld how your antenna for your HF system is transmitting, okay? What information is traditionally contained in a station log? Everything. Date and time, band, call sign, all of that stuff. Good. What, if any, amateur band is shared with Citizens Band Radio? None. David told us that. He knows this stuff because he's a pilot. Amateur radio, anybody know what band that's on? No. 11. It's on 11. 11 meters. Okay? And it's channel specific. Okay. So we really don't share that band with anybody. Okay? What is the appropriate action when operating on either the 30 or 60 meter bands? Yeah, so the military uses this, the forestry department uses this, FEMA uses these 2 bands, and if we have secondary privileges to that, so if we hear them talking or sending signals or whatever, we are required to move away, okay?
Yeah, so I shouldn't change my answer to B there then, huh?
No.
QFO.
You'll piss them off. Okay. Why is impedance matching? I gave a FEMA class to FEMA people a couple of months ago, and the director or assistant director of FEMA was on there, and I had 65 FEMA people in the class, and we got to that question, and she came on. She was so adamant. Don't you can't go there. I said, okay. She like freaked out. All right, anyway. Why is impedance matching important? So we get the maximum amount of power to our antenna. Okay. What does CL mean? No. CL means we're closing. We're done. Okay. That's just one of those things you have to kind of memorize. Why must cases of some large power transmitters be insulated from the ground? Yeah, why must it be insulated from the ground? Because most power supplies and large power transistors also act as capacitors, and they will short out. Okay, so that's why we have to keep them insulated. Okay, all right, cool, because they carry some serious power in there sometimes. Tony will tell you all about that. Which 2 devices in an amateur radio station might be connected using a USB interface? So we don't connect anything in amateur radio by USB. It's computer and transceiver. That's the only thing that we would connect to a computer. The only device we would use to connect to a computer would be either USB, serial, or parallel port. They don't use serial and parallel anymore so much, so that's what we would connect. computer and the transceiver. Okay. Which of the following can be determined with a field strength meter? And the best answer is the radiation pattern of the antenna. And it gives you a little explanation here. Okay. So we use the field strength meter not only to measure the power that the antenna puts out, but its radiation pattern. We do a 360 walk around from the antenna, and we can see how it's radiating. Okay. NPM, and that's this guy here, right? And we know it's NPN because it's got the little thingy is going out. If the little arrow was going in, it'd be a PNP transistor. Okay. All right, cool. This one everybody should know. As soon as you pass your test, /AG, knock yourself out, you're good to go. All right, let's try one more. We have time for one more, and this time we're going to ace it. Okay. I want you to think about the questions a little bit more carefully. So, all right. Tony, yes, I recorded this at your request, Tony. So this. Have a good evening.
That was an A.
All right, Tony. Thank you so much for being part of the class.
Bill. Appreciate it.
Thank you. No problem. My pleasure. All right. So Anirudh, what's another term for mixing of the two RF signals?
Let's say C.
Okay, cancellation?
Mm-hmm.
Okay. Does anybody disagree with that? Everybody likes that answer?
No, I don't think that's
I do.
Hey.
Anirudh, I think they're revolting against you, Anirudh. So they say A. So do you want to change your answer, or you want to stay where you are? Door number 1 or door number 2?
Okay, I'll go with the audience, number 1.
All right, let's see what they say. All right, cool. Bill is off Bradlin. Bradlin, why are HF scatter signals in the skip zone usually weak? Bradlin, you're grayed out. Can you hear me? Just hit a Y if you can. On your text. Oh, you can hear me? All right, good. I'm sorry, Bradlin. You were grayed out.
I hit the microphone like 40 times. It works sometimes.
Yeah. I've already had it dial in twice. So anyway, so why do you think?
I don't remember this part very much, but I'm going to go with D, delta.
Okay. Propagations is through ducts in F region that absorb most of the energy. Does everybody agree with that one?
No, try A.
Uh-huh. So here's one possible answer, and there's the other one. So Bradlin, those are your choices. From what I see on my screen here, this is what everybody's voting for.
Well, I'm going to go with everyone else because I don't remember this part very well, so.
All right, good. David, which of the following describes full break-in telegraphy? QSK.
Charlie, C.
All right, let's try that. Let's go with David. Let's go with Andy. Andy, how close to the upper edge of the 20-meter general class band should your displayed carrier be when using 3 kilohertz wide upper sideband? This is like the other question, but opposite.
How close to the upper edge of 3 kilohertz. So it would be the upper edge, 3 kilohertz below the edge.
All right, I like that answer. All right, let's go with Franks. Hey, Franks, why must the metal enclosure of every item of the station equipment be grounded?
Oh, that has to be D. You've asked this before, though.
Okay, well, we got it wrong, so that's why it's asking you again. So Franks, you get the next question. Which of the following describes the construction of a MOSFET?
Oh my God.
No, 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 no. No, no, no. So forget the MOS stuff. What do we know about FET? FET is field effect transistor. And there's a word that goes with field effect transistor.
I guess I'd have to say B. Let's try it.
Yeah. Okay. Good answer. All right, let's go with Greg. Greg O'Neill. Which of the following is a reason why a Yagi antenna is often used for radio communications in the 20-meter band?
Let's go with, I was going to say A, but that's totally wrong. Oh,
right,
no, actually, A.
Yeah, Yagi's, yeah, I'm sorry, go ahead.
Yeah, no, it's not an directional.
Right, because Yagis are beam antennas, so they focus. Yeah. I love the text answers I'm getting from everybody. Joyce is really into this. Joyce is going to ace this, like no problem here.
How about C?
Yeah.
It helps interference from other stations to the side and behind of the antenna. Yeah, okay, Joyce thinks you're right. All right, let's go with Joyce. Joyce, this one's yours. What configuration of the loops of a two-element quad antenna must be used for the antenna to operate as a beam antenna, assuming one of the elements is used as a reflector? Did you say C? I got a lot of text from you, so I don't know if you were answering this question or not. Let's give Joyce another minute here. What do you mean you don't know? Take a guess. And then you'll get it right when you take a test. So take any guess you like. Joyce says C. The reflected element must be approximately 5% shorter than the driven element. All right, we'll see if she's right. So let's pick on Judy. Judy, what is one advantage of selecting the opposite or reverse sideband when receiving CW signals on a typical HF transceiver? So you're in lower sideband, and then you go to upper sideband. I didn't hear your answer. I heard that you came on, but I didn't hear your answer, Judy. Sorry.
D.
Okay. And let's go with Ken. Ken, what is a microprocessor? Forget that, okay? I'll answer that question. All right, cool.
How do you do that one?
No. Come on, let's get serious here, Ken. What control is typically adjusted for proper automatic level control setting on an amateur single sideband transceiver? What do you adjust to get automatic level control working on your radio?
I'm going to say D as in David.
Okay. Let's go with Richard Lee. Richard Lee, what is the RMS voltage across a 500-turn secondary winding transformer if the 250-turn primary is connected to the 120 volts AC? Bradlin, have a good evening. Thank you for attending. Good luck with the exam.
This is the proportion one, and I'm going to need a calculator for it. So the thing is, I believe you divide 2250 by 500, and that gives you a proportion of the turns. And since you have the higher number of turns in the primary, you're looking for a smaller number off of the 120. So depending on what that proportion is, I'm guessing it's either C or D, but I don't have a calculator handy.
All right, so pick one. Which one would you like? Anybody want to do the math for him?
Yeah, B. It's B.
All right, so they're suggesting it's B.
They're suggesting it's
B. It's your question, so you tell me what you want me to do.
Okay, I believe that's...
It was 4.5 was the 2250 divided by 500, yeah.
4.5. Okay, actually, I think it is B because I think that's a step-up transformer.
Okay, so we'll go with B then. And Robert, which mode is commonly used for voice communications on the 17 and 12 meter band? Robert says A. Robert, I think you're going to do well here. Okay, and Anirudh, what is a capacitance hat when referring to a mobile antenna? I have a picture of it someplace. Yep.
That would be nice.
Well, I'm gonna look for the picture. You answer the question. It's really dopey looking. Maybe I don't. Nope, maybe I don't.
Not sure, but I'll say D.
D. Okay. All right, and let's pick on. Hey, Bill, do one. Come on, Bill. Which of the following is an advantage of a ceramic capacitor as opposed to other types of capacitors? I don't know that Bill's still on though. I don't see him lit up. All right, we'll try. How about David? David, what's the advantage of using a ceramic? Oh, no, that was Joyce. David, what's the advantage of using ceramic capacitors? And David says D, low cost. All right, cool. And let's go to Andy. Andy, which of the following frequencies available for a control operator holding a general class license? Where can he go?
To control it's all of them. D, Delta.
Okay. And let's go with Frank's. Frank's, what's the maximum height above the ground to which an antenna structure may be erected without requiring notification to the FAA and registration with FCC approval, provided it is not or near a public airport? And David knows the answer to this, but David doesn't count.
That's a guess. I say 200 feet, but that's a guess.
That's a great guess. Okay. All right, Greg. When sending CW, what does the C mean? We know that one, right? Greg?
Oh,
you know what
C, 100%. What the C means H. Yeah.
Okay. Well, you're going to get another one, Greg.
Okay.
That one was too easy.
Okay.
How does an S meter reading of 20 dB over S9 compare to an S9 signal, presumably a properly calibrated S meter? So what this question is really asking you is, what's the power gain or loss on 20 dB?
100 times stronger.
That's it. That's it. Don't let the form of the question, thank you, don't let the form of the question make you crazy. Joyce, which one of these things is a tapped inductor? You guys are answering it faster than I can. Joyce says A. Okay, cool. And Judy, which of the following is the purpose of a beacon station as identified by the FCC rules? What does it do?
A.
Okay. All right, cool. And let's go with Ken. Ken, which of the following is an advantage of a switch mode power supply as opposed to a linear power supply?
I think I'm trying D, Oliver.
Okay. Richard Lee. Which of the following modes is most commonly used for voice communications on 160, 75, and 40 meters?
I believe, I'm taking a guess, but I believe it is lower sideband B.
Okay. And Richard Lee, what's the approximate open circuit voltage from a modern, well-illuminated photovoltaic cell?
Half a volt B.
Excellent. That was too easy. You got another one. What does the that one's too easy too. What does the Q and QRV mean?
Q and QRV. D as in Delta.
Okay. And Robert, why should solder joints not be used with the wires that connect the base of a tower to a system of ground rods? How come? Robert says D. Okay, thank you. Anirudh, a vertical, I'm sorry, which of the following describes a beverage antenna? Robert's sending you hints.
I'll go with
he writes
D.
Coke, he writes Dr. Pepper.
Oh, boy. Wow. It's definitely not A.
No, I have to stay impartial. I'm just telling you what Robert's writing. He's writing Coke, Dr. Pepper, Budweiser. I'm just saying, you know. Charger?
B.
You say B? Okay, that's fine. And David, when general class licensees are not permitted to use the entire voice portion of a particular band, which portion of the voice segment is generally available to them?
Charlie.
Charlie, okay. And Andy, which of the following is an advantage of a horizontally polarized? Forget that. Okay, I'll give you that answer. Andy, why is impedance matching we have this one too, right? Well, I'll give it to you. So Andy, why is impedance matching important?
A, alpha, yeah, we had it.
Yeah, let's try another one. Here we go. Andy, which of the following causes opposition to the flow of alternating currents in an inductor?
Opposition to the flow of alternating currents.
What prevents it from playing nice?
Reactance.
Okay. And let's go with Franks. Hey, Franks. What circuit is used to process signals from the RF amplifier and local oscillator and then send the result to the IF filter of a super heterodyne? That's not so bad. That's not so bad.
It's either a mixer or a balance modulator, but I don't know which one it is.
Well, pick one.
I'll pick A.
All right. That sounds like a good one. Let's go with Greg. Greg O'Neill. Which of the following ionospheric layers is closest to the surface of the Earth?
That would be the alpha, the D layer.
Okay, thank you. And let's go with Joyce. Joyce, what is a possible benefit to radio communications resulting from periods of high geomagnetic activity? And Joyce, I'm not sure if you answered that one. That question. Did you say D? Is that your answer? Joyce says C, improved HF long path propagation. All right, and Judy, you have the honor of the very last question on the very last test we're giving in this class. In what ITU region is operation in the 7.175 to 7.300 megahertz band permitted for a control operator holding an FCC-issued general class license? That is the ultimate trick question.
C.
Okay. You said B as in boy?
B, yes, B, yes.
Okay. All right, here we go, guys. Much better. We failed, but we did it. We did it much, 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 much better. Let's just review the questions real quickly. So wherever we mix two RF signals, that's done by heterodyning. That's the term we use. Why are HF scatter signals in the skip zone usually weak? The answer was A. Okay, that's cool. Which of the following describes full break-in telegraphy? Okay, and that answer is full break-in. We need to get through, and you can receive between code characters and elements. All right, if you want to go into the answer a little bit more, you can just click here. Okay. All right, cool. This one you got right. So if you're at the very edge, top edge of the 20 meter, how should you be? 3 kilohertz, whatever this says, below the edge of the band, or else you fall off. We're on this edge now, so we don't fall off. We move back here. All right, cool. This one we know by heart already, so we don't hurt ourselves here. MOSFET. So whenever you see whenever you see FET, it's a gate. It's the only answer that makes sense with the gate. Okay. Why is this one not correct? It's got the word gate in it. Okay. Because any transistor does not have a back bias junction. Okay. And that's the correct answer. All right. Cool. Which of the following is the reason? Okay. Why is it used a lot in 20 meter? It helps reduce interference from other stations on the side or behind the antenna. It's directional. It's not omnidirectional. It's the opposite of that. It's extremely directional. Okay. We didn't know the answer to this one, not even a little bit. You were on the right path here. I think it was either Judy or Joyce had this question. You were on the right path. And actually the reflector element, which is the longest element, it's the one behind the antenna, the very last one, has to be about 5% longer. Okay, so the reflector element has to be the longest element. Okay?
And you said the driven was the shortest. It's at the front, right?
Correct.
Okay.
Okay. All right, cool. That was a hard one anyway. Why would we listen to the reverse sideband? So we're on either the lower sideband, then we switch to upper sideband, or we're on upper sideband and we go to the lower sideband, because a lot of times you can get through, you'll still hear the CW, but you'll eliminate a lot of interference. So if you're on the lower band and there's a million people around the CW operator, this only works for CW, okay? An easy way to do it is switch to the upper sideband. CW will get through, and you'll be able to hear them a little bit more clearly, okay? Microprocessor, we know what that is, okay? And to adjust the automatic level control, you always want to adjust the gain on your microphone, okay? All right, this one was a lot of math questions, and I didn't say anything, but you were on the right track. And that was your guess, and that's what you get for listening to somebody else. So if you do the math, okay, and you were right on the money, and you did 500 turns, but you forgot to multiply it by 120 volts. So you put the 500 over the 2250, multiply it by 120 volts, you got the answer. So
yeah, I did the division wrong for you. I did the reverse of it.
All right, and you were on the right track, and that's what matters, okay?
And it was a step-down transformer, not a step-up.
Yeah, but you did good. The point is you understood how to attack the problem, and that's good. That's great. Which mode is most commonly used for 17 and 12 meters? Upper sideband, okay? That's awesome. If you look at the study sheet and you look at that 20 meters, so anything above that 20 meter on that sheet, on the study sheet, and 17 and 12 are higher up on the list, use upper sideband. Anything lower than the 20, use lower sideband. Okay, that's an easy way to memorize that. Okay, a capacitance hat. Maybe I didn't discuss this enough with you guys. It's just an extension. And it's just a coil inside. They wrap some wire around. That's what a capacitance hat does. And it electrically lengthens an antenna. Okay, ceramic capacitors. If you get this one wrong, you never heard of me. And the only thing they have going for them is they're cheap. Okay, this one was cool. This one was a trick question, and that's in the upper part of your study sheet. We can transmit as generals anywhere here. Okay, please know this one. Okay, David and I will thank you profusely. Okay, if you do remember this one, if you're going to put up an antenna tower near an airport, please make sure it's over 200 feet. Not above 200 feet. Make sure it's less than 200 feet, because chances are we're coming in, and it's IFR, so we can't see anything, and we'd hate to meet you that way. Okay? So below 200 feet, anywhere near an airport. Okay? The C means chirpy in CW. We got that one right. This one, I'm glad that you got the hint. This is just 20 dB over, and that's on your study sheet, 100 times stronger. Symbol 7, you got this one right. Tapped inductor. Excellent, excellent job. Okay? And how do we know it's tapped? It's got a little wire coming out of it, right? So that's how we know it's a tapped inductor. All right. The beacon is for observation or propagation and reception. It just tells us where we can talk to. That's all it does. All right. Switch mode power supply over a linear power supply, something that's at one level all the time. We can use smaller components in a switch mode power supply. So that power supply can be physically smaller. That's what that reason for that. Which modes are most commonly used for voice communications on 160, 75, and 40 meters? Once again, go back to that study sheet. If it's below the 20 on that list, use lower sideband. All right. Photovoltaic cells, it's always 0.5 volts. Okay. Q means I'm ready to receive. All right. And why don't you use solder? Because lightning will destroy solder, no problem. Okay. All right. Beverage antenna. Okay. It's a very low and directional receiving antenna. And Robert threw you for a loop here when he says it's constructed of beverage cans. Actually, Robert was correct. The original ones were made from beverage cans, but the answer is how does it act as an antenna. It's very long, low, and that kind of stuff. All right, cool.
What does that look like? Did you have a?
I don't have a picture, but I will email you guys a picture of one, of a beverage antenna. And what they did was they took a stick, they put a can of Budweiser on it, and Robert's getting thirsty already, and they wrapped a wire around it, and that's where they got the name beverage antenna. It's cool. When you're not allowed to use all of the voice segment, you always want to go to the upper end. It's the lower end that they're concerned with. Okay, lower end, there's less attenuation, more signals get through, and it's for people making longer distance contacts. You may not have those privileges, and that's why they want you to be at the upper end of the voice segment. Okay, this is good. We answered this one already. Lower ground reflection losses. All right. Why is impedance important? We know that one now. And you got this one right. The opposition to the flow of electrons in an inductor, the opposition of that is called reactance. Excellent. All right. All right, cool. What circuit is used to process signals from the RF amplifier? I know it was a choice, but you chose. It was the other one. It's a mixer. Okay? So when we process signals from the RF amplifier and send the result to the filter of a set superheterodyne, that's what a mixer does. Mixes it all together. All right. Which surface closest to the Earth? D layer, that makes sense because it's D, E, F1, and F2. The closest one to the Earth is D. All right. What possible benefit is from high geomagnetic activity? I did not explain that enough for you. Geomagnetic activity is most closely related to the aurora borealis, the northern lights, and we can bounce signals off of that. So geomagnetic, think of the aurora borealis, and it reflects correctly. And Judy had the very last question, and she got it right. So we don't care about any of this stuff. All we care about is FCC General License Class. What does it control? Only Region 2. Okay? All right, guys. Listen, it's been a real pleasure being with you. I'm going to be around for a few more days. If you have questions, and no, Robert, I can't take the test for you, but I'll be glad to VE on any sessions you have. You're welcome, Joyce. It's been a pleasure. If you have any questions, email me, and I'll get you some answers. And if need be, I'll spend some more time with you guys as you may need. So thank you again so much for taking the classes. Have a wonderful night, everybody.
Hey, Joe, enjoy your vacation.
I sure will. Thank you so very much.
Thanks, Joe.
All right, guys. Have a good evening.
Thank you, Joe, for everything.
Please,
great.
Yeah, let me know how you guys make. I'd love to hear your. Hi.
Okay, will do.
Thanks, Joe.
Thanks, Joe.
You're welcome.